Good morning, dear students. A warm welcome to all of you for today's digital session for the subject Science and Technology, Section A. In our previous session on Saturday, we have completed with the discussion of textual exercise for chapter number 11, Reflection of Light. Also, I have discussed the additional questions for that chapter with you. Only two numerical examples are left behind that I will take up in our next session. Today we are going to start with the revision as our second online assessments are nearing now. The exams are very nearby. So we are going to start with the revision. So today we are going to revise chapter number 3 from section A, and on Thursday we will be revising chapter number 4, Measurement of Matter. That is a small chapter. So along with that chapter I will be taking up both the numerical examples. So let us start with the revision part. Current electricity. Now revising this chapter doesn't mean we are only going to prepare for our exams, but making the concepts from this chapter very concrete, making the basics very firm will really help you in the 10th standard, because you have an entire chapter based on electric current in the next year named Effects of Electric Current. So all the topics which we are going to revise, which we are going to study here, should be learnt and registered firmly in your minds. When we speak about current electricity, the moment you get up in the morning, this all appliances play a very important role. In the morning when you get up, you have heaters, geysers in your house, which enables you to heat the water for bathing purposes. You might be having electric ovens, tube lights, bulbs, fans, ACs, television sets. So looking at all these appliances, what comes in your mind? That really electricity is of utmost importance in today's world. We all depend on it for almost everything in our day-to-day life, and really you come to know its importance when the current goes away, when there is current failure. That time you come to know about the importance of electricity. And in this chapter we are going to study about the different concepts, scientifically the different concepts related to current electricity, how current is produced, what are the different terms related to it, that we are going to study ahead. And our first term for this chapter is about the electric potential, that is the charge between the electric charge between the 2 points. It depends on a kind of electric level at those points, which is known as electric potential. And here the first concept, very important, is that the flow of positive charge is from a point of higher potential to a point of lower potential. Earlier you have studied that electricity, it flows due to the conduction of negatively charged electrons, and electrons are negatively charged. So the electrons, they will flow from the point of lower potential to a point of higher potential. You might have learnt about the lightning. A lightning strike is the flow of electrons from the point of lower potential on the clouds to the point of higher potential on the earth. Now looking at this figure over here. In this figure you will see that conductor A, these are two conductors. So conductor A is at a higher potential, then conductor B is at a lower potential. When both of these are connected by a conducting wire means a wire which can allow the flow of current. So a potential difference is created between both the ends, and the electrons will flow from B to A. Why B to A? Because electrons are negatively charged. So they will be flowing from B to A through the conducting wire, and this flow will continue until both the conductors, that is A and B, they have the same potential. Means what? Until their potential difference becomes 0, and only then will the flow of electrons stop. Here you can see that work has to be done against the electric field to take a positive charge from a point of lower potential to a point of higher potential. Based on this, we are going to study the first definition and formula for this chapter, potential difference of a cell. Potential difference of a cell. What is the definition? The difference in potential between the positive and negative terminals of a cell is the potential difference of that cell. The formula is work done upon total charge transferred. Potential difference is denoted by capital V. So V is equal to work is capital W upon the denomination for charge is capital Q. So V is equal to W upon Q, that is work done in transferring the amount of charge. So when you can say that the potential difference is 1 volt, potential difference is 1 volt when 1 joule of work is done in moving 1 coulomb of charge from one point to other, and the SI unit of potential difference is volt. I had told you that this unit of potential difference is named in honor of the scientist Alessandro Volta. He had constructed the first electric cell, and hence the SI unit is a recognition of his work. Now, as I had told you last time that the current flowing through a wire is nothing but due to the electrons which are present in the metallic wire. So every atom of a metallic conductor, it has one or more outermost electrons which are weakly bound to the nucleus, and they are called as free electrons. And these electrons, they can move easily from one part of the wire to the other parts, and hence as these electrons are negatively charged, the negative charge of the electrons, it also gets transferred as a result of this motion. Now let us see the motion of free electrons with the help of a diagram. You can see there are two figures, figure A and figure B. As you can see in the first figure, that is figure A, if a conducting wire, it is not connected to any cell, then its free electrons move randomly. You can see the random motion of the electrons in all the directions in the space between the atoms. See the random movement, we see the random motion of the electrons. But when we connect the ends of the wire to the two terminals of a cell, you can see in this diagram B, what will happen? Immediately the electric force will act on this negatively charged electrons. Being negatively charged, what will these electrons do? They will start moving from the negative charge or the negative area, negative potential, to the positive terminal of the cell, that is from the lower potential to the higher potential. And what happens due to their movement? Current starts flowing through the wire, and what you can see here is that flow of electrons produces or generates current in the wire. So current is nothing but the flow of electrons in any metallic conductor. Now let us see the real definition of current in scientific sense. What do you mean by current? Just now I have told you that electric current is nothing but the flow of electrons through a conductor, and quantitatively we can say that current, which is denoted by capital I, is defined as the charge passing through a conductor in unit time. So what is current? It is nothing but the charge which is flowing, which is passing through a conductor in unit time. So if charge is denoted by Q, and Q charge is flowing through the cross section of a conductor in time t, then current I is equal to Q upon T. So here you have got the definition for current and the formula for current. So henceforth you have to remember that current, when you have to denote, you will denote it by capital I. So capital I is equal to Q upon T. Now charge, unit of this charge is coulomb. So SI unit of charge is coulomb. SI unit of current, I is ampere. So when you have to denote coulomb, you will denote it by capital C. When you have to give the unit for current, you are going to write as capital A instead of ampere. So when you can say that current is 1 ampere, we can say that 1 ampere current is said to flow in a conductor if 1 coulomb of charge flows through a conductor in 1 second. So 1 ampere is equal to 1 coulomb upon 1 second. All these formulas should be learned by you thoroughly. The unit for current, the unit for charge, everything should be known by you. It can be asked under MCQs, and also this part is an inseparable, you can say, topic when it comes to physics. Our next very important concept from this chapter is resistance and Ohm's law. What is Ohm's law and what relationship does it show? The relationship between the current which is flowing through a wire, that is I, and the potential difference across its ends, that is V, it can be obtained from the law that was put forth by the German scientist George Simon Ohm, and hence it is known as Ohm's law. So what does this law state? That if the physical state of a wire, if the physical state of a conductor, it remains constant, then the current I flowing through that wire, it is directly proportional to the potential difference. In short, what is Ohm's law? I directly proportional to V. Now here, what does the physical state means? Physical state of a conductor, it means its length, area of cross section, temperature, as well as the material of which the wire is made up of. So when you say I directly proportional to V, to remove this sign, we will take K as the constant of proportionality. So I is equal to K multiplied by V. So I multiplied by 1 upon K is equal to V. This K, if you take here, it will be 1 upon K. So what is 1 upon K? It is taken as R, which is resistance of the conductor. So in place of 1 upon K, you will write as R. So I into R is equal to V, or V is equal to IR, and this is known as Ohm's law. So in short, what is Ohm's law? I directly proportional to V, and what is the formula? V is equal to IR. And in honor of the work of George Simon Ohm, the unit of resistance is also called as Ohm, which is denoted by this symbol. So when we can say that resistance is 1 ohm, when 1 ampere of current flows through a conductor and when 1 volt potential difference is applied between its ends, then we can say that the resistance of the conductor is 1 ohm. So up to here we have studied 1 ampere current, then we have studied about 1 you can say volt potential difference, and we have studied 1 ohm resistance. So all the definitions, learn it by heart for the coming exam. Our next topic is resistance and resistivity of a conductor. Resistance and resistivity of a conductor. What do you mean by resistance? As I have told you, we had seen in this figure previously that there are a large number of free electrons in a conductor. You can see here in a metallic wire, a large number of electrons are flowing which are in a state of random motion. So when a potential difference is applied between the two ends of the conductor, the electrons which are negatively charged, they start moving from the lower potential to the higher potential, and this directional motion of electrons, it causes the flow of current. This we have seen in the previous topic. So this moving electrons, they strike the atoms and ions which lie along their path. Now the electrons, being in a state of random motion, they are going to strike with other electrons which are found in their path. Also they are going to strike with the atoms or the ions of the atoms which the conductor is a part of, and such collisions, they cause hindrance, they cause some opposition to the free flow of electrons and oppose the free flow of current. This hindrance is called the resistance of the conductor. So in short, what you can say, how you can define resistance, the property of a conductor due to which it opposes the flow of current is called resistance, denoted by capital R, and you all know SI unit of resistance is ohms. The next topic is resistivity. At a given temperature, the resistance, which is denoted by capital R, of a conductor, it depends upon the length L and the area of cross section A, and also the material of which the wire is made up of. So if the resistance of the conductor is R, then R directly proportional to the length, R inversely proportional to area. So if you combine both, you can see here it is equal to L upon A. To remove this sign, we are going to take the constant of proportionality, which is called as rho. So capital R is equal to rho L upon A. This rho is the constant of proportionality and it is called the resistivity of the material, and unit of resistivity is ohm meter. Be very careful with the units. Unit of resistance is ohms. Unit of resistivity is ohms meter. So up to this topic, so many units we have studied. The very first we have studied SI unit of potential difference is volt. Then we have seen SI unit of current is ampere and charge is coulomb. SI unit of resistance is ohm and SI unit of resistivity is ohm meter. Make a chart and study it. Our next very important topic which we are moving towards is electric circuit. Electric circuit. What do we mean by an electric circuit? You can see a circuit diagram over here. Here you can see an ammeter which measures current. It is connected in series. A voltmeter which measures the potential difference is placed in parallel with the resistance. You can see here an electric cell with positive and negative terminal, a conducting wire. You can see these arrows. They denote the direction of flow of current. So what is an electric circuit? A continuous path of an electric current through the conducting wires connected to the two ends of a cell. Two ends of the wire, you can see they are connected to the two ends of a cell and other resistances. It is called an electric circuit. Now an electric circuit is depicted by a figure. This figure, it shows how the different components are to be connected in the circuit. How? By using special symbols for each of the components, and that entire chart which shows the symbols for the components and their uses, they have removed that topic from the syllabus due to the pandemic. But as I have told you, page number 36, that chart you just go through, not before the exam but after the exam in the Diwali vacation, because that chart is extremely important when it comes to this concept or this topic from physics. So our next topic is about the conductors and insulators. In the beginning only I had told you conductors. This word tells you that something is being conducted, and when this is chapter electric current, then it is about the conduction, the flow of electricity through a wire. So what is a conductor? Any material, any substance which allows the current to pass through it very easily. The substances which have very low resistance and through which current can flow easily is called an conductor. On the other hand, what is an insulator? The material which restricts the flow of electric current because it has extremely high electrical resistance, and such substances are called as insulators. So which are the examples of conductors? Most of the metals, copper, aluminium, silver, all these are examples of conductors. On the other hand, plastic, rubber, glass, wood are the different examples of insulators. And hence you should know that the actual wires which you handle, that is not the wire, that is the insulating part of the wire. If you just cut it with the knife, inside you can see from the cut the actual copper wire can be seen. So whatever you are handling with the wire, that is not the actual wire, that is the insulating or a coating or the coat present on the wire, actual wire, that is made up of insulating material like plastic. Now our last topics to end with this revision or this chapter is about the two derivations, which are very important, not only from the examination point of view but also when it is related to this chapter. Two derivations are there. One when the resistors are connected in series and other when the resistors are connected in parallel. What is a resistor? It is a two-ended component having a given amount of resistance between its two ends. Now in several electrical devices or appliances, a number of resistors are connected together in different ways, and which law is applied here? Ohm's law is applicable to all such connected resistors. So our first is system of resistors which are connected in a series combination. Now what is a series combination? You can see in this given circuit diagram, the ends of the three resistors R1, R2 and R3. They are connected so that they follow one after the other in a single line. What you can see, R1, R2 and R3 are the three resistors which follow a linear pattern one after the other, and these resistors are hence said to be connected in series. What is the special characteristic of this arrangement? Same current flows through each resistor, that is current which is denoted by capital I. So what we can say that in a series combination, current remains same in the entire circuit. Potential difference between these points C and D, take a care, potential difference between both the points C and D is V. So total potential difference is V. Now you can see that the three resistors R1, R2 and R3, they are connected in series. So V1, V2 and V3 will be the potential differences for R1, R2 and R3 respectively, and the total potential difference V will be the sum of the potential difference across each resistor. So total potential difference V will be equal to V1 plus V2 plus V3. Now we are going to apply Ohm's law. Just now we have studied about Ohm's law. V is equal to I into R. Now here they have taken RS. Why S? Because resistors are connected in series. And if it is parallel combination, then we are going to take RP. So what will be V1? IR1. V2 will be IR2. And V3 will be equal to IR3. Now this values of V1, V2 and V3 we are going to substitute in this equation, and this general value of V we are going to substitute here. So our next part of the derivation will be IRS. You can see over here in place of V we are going to take IRS, in place of V1, IR1, IR2 and IR3. So IRS is equal to IR1 plus IR2 plus IR3. If I is taken common on both the side, it will get cancelled off. So RS is equal to R1 plus R2 plus R3. This is for three resistors which are connected in series. But for n number of resistors connected in series, it will be RS is equal to R1 plus R2 plus R3 plus Rn. That is for n number of resistors. Now for this, you can say combination, series combination, what are the different characteristics? It can be asked in the exam. So the first characteristic is same current. Current remains constant in the circuit, or the same current flows across each resistor. The total resistance of the resistors is equal to the sum of their individual resistances. Effective resistance, that is RS, just now we have seen over here. RS is equal to R1 plus R2 plus R3. Means what? The effective resistance is equal to sum of the individual resistances. The potential difference between the two extremes of the arrangement is equal to the sum of the potential difference across individual resistors. We have seen total potential difference V was equal to V1 plus V2 plus V3. The effective resistance is larger than the individual resistances, and this arrangement is used to increase the resistance in a circuit. So these are the characteristics for resistors connected in series. Now let us see the other derivation for resistors connected in parallel. Here you can see, when you can say that the resistors are connected in parallel, when their ends, this R1, R2 and R3, when their ends are connected at both the sides, you can see one upon the other. So here are the three resistors R1, R2, R3, which are connected in parallel between points C and D. The special characteristic of parallel combination is potential difference, which is V, it remains constant. What was the case of series? Their current was constant. Here potential difference is constant. The currents across each resistor will be I1, I2 and I3. So for R1 the current flowing will be I1, for R2 it will be I2 and for R3 it will be I3, and so the total current will be equal to I1 plus I2 plus I3. Apply Ohm's law. I is equal to V upon R. As I have told you previously, parallel combination you are going to take as RP. So I1 will be V upon R1, I2 will be equal to V upon R2, I3 will be V upon R3. Substitute in this equation. I is equal to I1 plus I2 plus I3. Substitute the values of I1, I2 and I3. So it will be V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. Taking V common on both the sides, it will get cancelled off. So what remains? 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So for n number of resistors, it will be just continued plus 1 upon Rn. So this is the derivation for parallel combination. You have seen how you have to study both the derivations. You will see that in both the cases 3 resistors are used. Series combination, current remains constant. Parallel combination, potential difference remains constant. Both the cases, first case as current is constant, total potential difference is the potential across the 3 resistors. Here the total current is equal to current flowing across each resistor. Apply Ohm's law in both the case and you will get the final formula. So what are the characteristics for resistors connected in parallel? The inverse of the effective resistance 1 upon Rp is equal to the sum of the inverses of their individual resistances. See here, inverse of the effective resistance is equal to sum of the inverse of their individual resistors. That is your first characteristic. Second, the current flowing through an individual resistor is proportional to the inverse of its resistance, and hence what is the total current? It is the sum of the currents flowing across individual resistors. Potential difference is same. Effective resistance of resistors connected in parallel is less than the least resistance, and this arrangement is used to reduce the resistance in a circuit, whereas series combination is used to increase the resistance in the circuit. So with the end of both these derivations discussion, I declare that the revision for chapter number 3 is over. Now it's your time. The more amount of marks you want in the exam, the more amount of reading of each chapter should be done from your side. As I have told you initially also, yes, from the textual exercise I have covered in the question paper, but maximum of the objectives are asked from within the textbook, making you aware that for the board exams also you have to read the textbook. Each and every chapter should be read by you at least minimum 2 times. So each and every topic you will be very thorough with. Now for the textual exercise, question number 4 was omitted. I had told you that it will be taken later on, but now that question number 4 is omitted because it is based on Ohm's law, and Ohm's law, experimental proof of Ohm's law, that topic they have removed out from the syllabus due to the pandemic. So textual exercise question number 4 will be omitted. other textual exercise, numericals, everything I have covered for you. So on Thursday, that will be our last session before the online assessment. We will be revising chapter number 4, measurement of matter. Section B, the revision is completely over. Section A, 1, 2, both these chapters we have already revised for the first online assessment. 3 I have revised today, 4 will be taken up on Thursday, and reflection of light we have just completed very recently. So I hope that you have read the chapter and all the notebooks, everything is completed from your side. So best of luck for your preparations for the exam. We wind up our today's session here, and be prepared, read the chapter number 4 before you attend our next session. And along with chapter number 4, I will be taking up the both numerical examples for chapter number 11 which are left out. Thank you, dear children.